Okay, so this video is going to take you through the 3 example problems that we'll be doing in class. Your job, if you're doing this in the lesson, is to copy down the work into formative as it is presented on the screen. Do make sure that you're listening to the video though, because sometimes I might show you something and for to illustrate a mistake and then erase it. So don't make sure you're listening. Okay, we'll just put it that way. So suppose you are asked to factor this. We have x squared minus x minus 2 over 2x squared plus 5x plus 3. Now, your first instinct might be, oh, what can I cancel? Oh, I got some x squareds, I got some x's, we're going to cancel it all out. But remember the point from the previous video. You cannot cancel common terms. So what we need to do is we need to go through the oh so much fun process of factoring in order to see what the factors are, because they have to be factors before we can cancel them. So over here, we're going to do our scratch work, and I'm going to try to factor x squared minus x minus 2 first. This one is got the one that has the x squared, so that's pretty nice. And we know the x squared is upper left, -2 is lower right. And we're going to look at factors of 2. That's awesome that it's a prime number, so 1 times 2, that's all we got to pick from. And we need those to add up to a -1. And so if I want those to add up to a -1, then it is the 2 that would need to be negative. So we'll have positive 1x and negative 2x. And now we can go ahead and factor that. So x times x gives me x squared, x times 1 gives me 1x, x times -2 gives me -2x. And then that check of the fourth box, x plus 1, 1 times -2 is -2. And so my numerator over here is going to factor into x plus 1 times x minus 2. So there's the numerator. Now we have to factor the denominator. Now here's a pro tip, okay? Maybe not in general, but when you are studying rational expressions, so you're in a unit like the one we're in now, we're covering it really fast. Usually something's going to cancel out. So what that means is that in my denominator, I'm expecting one of the factors to either be an x plus 1 or an x minus 2, because I am expecting something to cancel out. And that can be really helpful when you're trying to do the factoring and figure stuff out, because it kind of gives you a hint like, hey, probably something's going to cancel out. Now, that doesn't mean stuff cancels out all the time in every single situation, but if you're studying simplifying rational expressions, probably something does. So let's go ahead and take a look at the second one. So we have 2x squared plus 5x plus 3, and we'll set up our area model. We're going to have 2x squared, or you could do a 2x cubed. Don't do that. Don't make it a cubic. And we have the 3, and then this is one that has the leading coefficient, so we have to do 2 times 3 to get 6. And now we're looking for 2 factors of 6 that add up to 5. Now we got to be really careful here, because we could have 1 times 6 or we could have 2 times 3. And the catch here is that both of those could give you a 5. So you could get a 5 by doing a -1 and +6, or you could do a +2 and a +3. So what do? We got 2 different factors that can add up to that 5x. Then just kind of kick back over to the multiplication piece. When they are multiplied, they're supposed to give me a +6. So we had a +6, so it was +2 times +3. So it's supposed to give me a +6, and so -1 times 6 won't do that. And so it's got to be the 2 and the 3, which is good. I mean, I'm happy with that. So we have 2x and 3x. Now on this one, typically when I factor, I just typically factor this direction, but this time I'm going to factor this direction right here, because I don't have the common factor of 2. So what do 2x squared and 3x have in common? Because 2 and 3 don't have anything in common. It's just got to be the x, which means that this must be the 2x. 2x times 1 would give me 2x, and x times 3 would give me 3x. And so my factors would be 2x plus 3 and x plus 1. And now you can see that we have common factors. So you might say, well, wait a minute, Ms. Taylor, though they're not lined up. Does the x plus 1s, do they have to be lined up? No, because multiplication is commutative. So I wrote 2x plus 3, x plus 1, but I could have written x plus 1 and then the 2x plus 3, like I did up here. I did the x plus 1 first, and then I did the x minus 2 second. Multiplication is commutative, so it actually doesn't matter what order they're in. These are your factors, and common factors can be canceled out, and that leaves me with x minus 2 and 2x plus 3. So that is my first simplification problem. Next one is x squared plus 5x over x squared plus 3x minus 10. And we do need to do our factoring, because you cannot cancel out those x squareds because they are terms, they are things that are being added. So you have to do the factoring. If there were a shortcut, I would tell you the shortcut. If there was some way to get around the factoring so you didn't have to do it, I would tell you what it was. So let's take a look at this first one. X squared plus 5x. That has a common factor of x. So you've got x squared and then you have an x. So we would take the x out. X times x is what would give you the x squared, and if you factor out the x there, you're left with a 5. So the numerator here is x times x plus 5. And here's the good news. Probably in my denominator, I am either going to have an x or I am going to have an x plus 5. Not 100%. I don't want you guys, thinking, oh, it's got to come out that way, but it probably will. All right, so here's our second one. We set up our area model. We've got x squared, we've got negative 10, and so we want factors of 10. Well, that would be 1 times 10 or 2 times 5, and that's it. And I need them to add up to 3. Because I got the 3 there, so that would be like a negative 2 and a positive 5 would add up to 3. And we can double check. Negative 2 times 5 does give us the negative 10. So we have negative 2x and 5x. And then that gives us x times x, and then negative 2, and then 5. And you'll notice I'm doing that much faster because we did review it. And now I have common factor of x plus 5, and that can cancel, leaving me with x over x minus 2. Now, again, this is where you just gotta plow through that factoring. Just gotta do it. All right, last one. I want to change my color up. Okay, so this will be 4x plus 2 over 4x squared plus 6x plus 2, and we're going to need to factor that. In my numerator, I have a common factor of 2, so in the numerator, and again, if you don't see it, like 4 is 2 times 2, and 2 is really 2 times 1, okay? That might be important to just remember, especially on this particular problem. Because when I factor out the common factor, we will be left with 2x, and then a lot of times students will say, oh, I'm left with 0. No, you're not left with 0, you are left with 1. And so my numerator is 2 times 2x plus 1. And again, I am expecting to see in my denominator either a 2 or a 2x plus 1, maybe both. I don't know. Let's take a look. So we have 4x squared plus 6x plus 2. And the first thing I notice is that, yep, those are all even numbers, which means I can take out a 2. 2 times 2 would give you the 4. 3 times 2 would give you the 6. And then, of course, it would be 1 times 2. So I do have the 2. Now we've got a factor. The rest. You have a 2x squared and a 1. And I like it when we have 1s in there. because we will do 2 times 1, which gives us a 2, and we want two factors of 2 that add up to 3. Oh, look, 1 times 2 is 2, and 1 plus 2 is 3, meaning we have a 1x and a 2x. And we're going to do GCF factoring. So what's the common factor, greatest common factor between 2x squared and 1x? That would be an x, which makes this 2x, which makes this a 1, and makes this a 2. And so we have in the denominator 2x plus 1 and x plus 2. Wait a minute. 2x, whoa, no, this is 1. Right here, this is a 1. Yeah, okay. I like looking, I'm like, wait a minute, that doesn't work. 2x times 1 gives me 2x, and 1 times 1 is 1. A 2 would not work there. And you'll notice, I mean, that was a legit mistake. I had to stop in the middle of the video. I don't like doing that. So you just gotta look at something and you're like, wait a minute, this doesn't seem right. This feels wrong to me, and go back and check it. So this makes this an x plus 1. And now in this one, we actually have 2 common factors. We can cancel out the 2's, those are being multiplied. And we can also cancel out the 2x plus 1's. So my final answer then has an x plus 1 on the denominator. You have to think for a second what's left on the numerator, because you just can't leave nothing in the numerator unless you're measuring frequency of a sine wave. You know what, don't go there. But what we got going on is similar to when you're factoring, all of that is times 1. You could also think of it as 2 over 2. Like, what is 2 divided by 2? It's 1. And so this one, the final simplification would be 1 over x plus 1. So another little bit of a lengthy video, not super bad, but that goes through the example problems.